right, well, here recording. Okay, so here's what we're going to do. I'm going to screen share. Go ahead and open up Excel if you want, because you guys are probably going to want to practice on Excel more than anything, right? Yes. Okay, so here's what we're going to do. A survey asked first-year college students how many hours do you study in a week? Okay, if we're reviewing, you need to be with me, okay? Cut down on the talking and let's be with us here. 463 students responded, and mean there, and X bar equals 13.7 hours. Suppose we know that study time is normally distributed with a standard deviation sigma equals 7.4 hours. Part A, find a 99% confidence interval, and B, what condition must be met for a confidence interval to be valid. Okay?
For what we call it?
A confidence interval. And just in case you're wondering, this is 16.19. Okay? So, how do you do this? Do you want me to focus mainly on the computer, or do you want me to do both? Computer or paper? Okay?
So we write out the numbers.
So write out the numbers. Okay, what are the numbers we need here? N is 463, X bar 13.7, sigma, it says sigma, hopefully you can figure that out, 7.4. Okay? I will. Do you want me to pass out formula sheets?
Yeah.
You'll just need to pass them back at the end of class. Yeah. So, yeah, so you'll have these formula sheets. Do I want to pass out tables? Do you have your own tables? I just got these sheets here. I'll just need these back at the end of class, because otherwise you won't get them for your test on Thursday. All right, so what's the equation that we need to use for this? Yes?
The X bar plus or minus T sub alpha, X over square root.
What did you say?
T sub alpha.
T sub alpha? alpha over 2 times, or sigma? Is it S or sigma? Are you sure? What does the equation say? Because I think you're mixing up two.
Wait. S, isn't it if you have the standard deviation, then you use Z?
Yeah, don't you use Z, not T? Do we know sigma?
Yeah.
Since we know sigma, it's T, it's Z, not T. Z sub alpha over 2 times sigma over the square root of m. Okay? When would we use T? We don't have sigma. Okay? All right. So in this case, let's do a lower, let's do an upper, and we're going to get x bar minus, oh, z. We probably should figure out our z sub alpha over 2. Z sub alpha over 2. You guys know how to find this without the tables? Because I didn't give you the table. I gave you the formula, though. Your formulas are at the bottom of your sheet there. Is it norm as dis or norm as inverse?
Inverse. Oh, yeah, because it's a piece word from probability.
Norm as inverse.
Okay. So.
It's on your sheet. It's the second command on your sheet. Okay? Norm as inverse, what probability do I want? We're doing a 99% confidence interval. So how much is in the tails? 1%. 1%. And so how much is in half of a tail? 0.005. Okay? So I'll get the negative number, and then because it always tells me to the left, I can do norm S inverse of 0.995 to give me 5% on the right, or 0.5% on the right. Okay, so that's where you get your plus and your minus from in the equation. Okay. Normally we don't use the negative, we just use the positive.
I swear we did not touch this.
It's a good thing we're reviewing it, okay?
How do we do it if you were writing them?
If you're writing it, you would use the chart.
And you would look for.
Here, I'll show you the chart here. So here's my chart. Normally, we're going to the normal distribution. We're looking under confidence level. You're going to pick 2.575. It's right there.
Right.
Okay? Wait, what? Right there. See it? Okay. So the chart is 2.575. The table is going to be a little bit more accurate. Okay. So it's going to be x bar minus this value times, huh? Oh, I selected N, you're right. X bar, how about that one? Times Z times sigma divided by the square root, it is minus of 463, and this should be a minus. Okay?
Where are you getting that equation for the lower?
Right.
Confidence interval?
Yeah.
For X?
What?
Huh? Which equation are we doing?
This is great because you guys don't even remember doing this problem. It was like a month ago, right?
Yeah, so for the,
Okay.
the inverse.
So I'm going to copy and I'm going to paste that, and I'm going to change the minus to a plus. Doesn't the test open tomorrow, by the way? I can't remember.
Yeah.
I think I got to write that test today too. Got 3 tests opening tomorrow. Do you guys have till Friday?
Yeah.
That's weird, because my other classes are bigger and they will not, they're making them stop on Thursday. Okay.
Do we still have until Friday? Because that's when I scheduled my Excel.
If they let you schedule it, that should be right.
Okay.
Because didn't they look it up?
I don't think so. I don't know.
They didn't look it up? I better look it up now. You're making me scared. All right, so let's pick on Riley. Can you give me a 99% confidence statement?
On mine, I just.
Well, you can look at mine.
99, what did you say?
Confidence statement. Do you know? Okay, go ahead.
Okay, I was going to say we are 99% confident that our results will be between.
Don't say results, that's too vague.
Oh, shoot, sorry.
That,
That's the average amount of study time that.
don't say average.
Shoot, the mean.
The mean
I'm sorry.
study hours
Versus college students.
for first year college students is between
The lower and the upper.
12.81 and 14.86 hours per week.
99% says we are confident that 99% of our results will be between this, right?
No, that's a false statement. We know our results are 13.7. We're 100% confident that our results were 13.7. What we're trying to do is we're trying to expand this not to just our results, we're trying to expand this to the whole, all first-year college students.
Does that mean that 99% of all first-year college students will fall within this range?
Does that mean that 99% of first-year college students will fall in this range? No.
We're 99% confident.
That is a false statement. We're saying that we're 99% confident that the mean is between those.
That's right.
Now, the students are going to be a lot more variable than the mean.
Right.
Okay? If you remember the central limit theorem from last test, who's already forgotten? Remember, the mean is always going to have a much smaller standard deviation than the population. Okay?
Right.
Yes, Gage.
On your two things, you have 12.81 and 14.86. Where did the 14.86 come from?
That's the upper.
Right here.
That's 14.58.
Oh, did I type it wrong? Yeah, 14.586.
Okay, that's
What happened.
That's the reason I was like, oh, where did that
Yeah, I
go?
missed the decimal there.
So what's the difference between the lower equation and the upper?
Plus and a minus.
Plus or minus, yeah. Yeah, plus or minus, yeah.
Okay?
Wait,
What condition must be met for the confidence interval to be valid? That's a good written test question.
SRS?
Must be a simple random sample. What else? Come from normally distributed population, which it told us.
And also greater than 30. Or is that something else?
Technically, if it comes from a normal, well, or 10 should be greater than or equal to 30. If you don't know it's normally distributed, actually no, I'm going to take that back. That one's for the t distribution, not the z. If it comes from a normally distributed, you could technically get away with a 1, but why would you do that?
So I have a quick question.
Okay.
So on the test, will it just say find a 99% confidence interval, or will there be other questions?
Yes.
Yeah. Will it say you need to
If
find
it says, if it says to find a confidence interval, you should include a confidence statement with that, even if I don't ask.
So, but will it say you need to find the n, you need to find the x bar, you need to find the sigma?
No, probably won't say that.
Okay.
You should just do that on your own.
Okay.
Okay? Good question. You ready for another one? Yes.
how did you know that when you were doing the upper sentence to do 0.995?
How did you know? That's a good question. Let me draw a picture. That's how I know. Okay? And in fact, I skipped the picture, but you guys should not, okay? So the question was, how do we know it's 0.995? We can see this. We're going to use a darker pen. In fact, let me turn on the light too. Okay. I'll draw it over here. If we're doing a 99% confidence interval, how much do I want in the tails? You want 0.5% here and 0.5% here, right?
Yeah.
Okay. So when we did the norm S inverse, remember the norm S inverse only takes what's to the left. So from this point here, what is to the left of this line? 0.995. Do you see that?
Yeah.
And so when you do that, that'll give you the positive number. This will be the negative number.
So if we're doing the negative number, we do 0.005. Do we still do the norm inverse?
Yeah.
We do the norm inverse because that'll go to the right.
Yeah. So remember, inverse gives you the critical values. Dist, maybe I should box that. Dist gives you the p-value. Okay, that's the difference between inverse and dist. So t dot inverse, norm S inverse, chi-square inverse, etc., etc. I guess you didn't learn that one, but it would do the same thing.
So when we plugged in the 0.995.
So 995 gives you this value here, which in our case was 2.575, right? That's how we got that value. But if you did, okay, so norm S inverse of 0.995 equals 2.575.
That's our actual value.
Norm S dist of 2.575 gives you 0.995. They are inverse functions of each other.
I'll check that out.
That is that.
So norm S inverse takes your percentage essentially.
It takes your percentage and gives you the critical value, or the standard deviations. That's another way to
Oh,
do
so
it.
that's the standard deviation.
Yeah, if I go 2.575 standard deviations away from the mean, 99.5% is to the left.
We're saying at 99.5%, it's going to be 2.595 standard deviations over that way, and 2.5
Yeah.
the other
So
way.
that's why these are what we call inverse functions. It's like square and square root.
I love it.
Okay?
What chapter was the inverse functions?
Every chapter that we've been working on.
Had inverse functions?
Okay? All right. Next question.
Because we use that when you're dealing with confidence intervals.
You need inverse if you're dealing with confidence intervals. You need dist if you're using p-values. Okay?
Should we do it on paper?
In case I forget to give you the formula sheets in the testing center, you'll still know it now. Okay? All right. Are we ready for a new problem?
Yes.
Oh, I'm just going to pick one. Did we do chapter 17?
Chapter 17, what was the title?
Tests of significance, the basics. I think we skipped that one.
We did. This is where we learned all the steps.
Okay, let me share here.
So is the written test going to be multiple choice, or is there going to be some answers that we're going to have to?
Yes, it'll be just like all the other tests.
How many questions is the written portion?
I don't know. 20, plan on 20 to 30.
Why did that?
Oh, this is a good one. No, it's not. Oh, here's a good one. Okay, this is example 20.3. In 2016, the Ohio Department of Health collected water samples from 12 beaches. Water is unsafe if it contains more than 88 coliform bacteria. Here are the fecal coliform data found. Is there evidence this is unsafe? Okay. Two 46, 37, 146, 19, oops, 19, 66, 236, 164, 30, 13, 144, 242, and 20. Okay, so how do we do this?
Find all of our numbers.
What'd you say?
Find all of our numbers.
Find the numbers.
N is 12.
Find the numbers. Is it 12 for sure?
Yes, because we counted twice.
12 it is. N equals 12.
X bar is the average.
X bar equals average of this.
All of it.
We got 113. Does that seem unsafe to you?
Yeah.
Yeah, it sure does. Okay.
Why, is that because it's more than, oh, okay, it's more than 88?
Yeah.
This is huge outliers.
Let me read this again really quick.
Yeah, this one.
Okay.
Oh, yeah.
What else? Is it sigma?
I don't know, is it?
I don't know.
No, it's a sample.
Sample, so
It's a sample.
Yeah, dude.
So it is.
So it's not sigma, it's S, right?
right.
That's an important.
STDEV S.
There you go. Right there. Grab that. There you go.
Okay. What do you think about standard deviation?
I think that is a huge standard.
That is a huge standard deviation. Okay.
How did you, will you click on the next three button? Oh, oh, yeah.
Okay. Also, what do you think of the N?
Small.
I think it's tiny.
Pretty small.
We need to do more,
Okay.
more details.
Now, the funny thing is I'm looking at the, here, tell you what, I'm going to cheat. I don't want you to do this on the test, but just for fun, let me do this really quick. Insert. We're going to use their stupid histogram maker, which sucks, but I don't want to spend time on this.
First both days.
Isn't that a terrible histogram? Does that look normally distributed to you? No. Can we proceed technically? No. This is not normally distributed, but for the sake of practice, we're going to pretend
Is that true of any test?
it is normally distributed. Okay, yeah. So 12 is too small. I did my histogram. Now I could probably do a manual one. I have a manual one in the book. The manual one in the book doesn't look normally distributed. Okay. This is probably not a test that we should do, but for sake of practice, we're going to pretend that it's normally distributed and we're going to do it anyway. Okay? So we're going to pretend it's normally distributed, but yes, this one has some serious problems, right? And in fact, well, the 5-number summary ought to be interesting. One of the other things is there should be no outliers, right? No outliers. How would we find outliers? 5-number summary, which is minimum,
Median,
Q1, median,
Q3, max.
Q3, and max. Here, let's do this really quick, okay? So equals quartile. Which one do I pick? The bottom one. Don't pick any of the other ones, only pick the bottom one. I'm going to click on this. I'm going to F4 it, and then I'm going to click on 0, right? I'm going to copy that down. All the numbers should be the same. Now I'm going to change that 0 to a 1, and a 2, and a 3, and a 4. Let's find your interquartile range. Q3 minus Q1. That's a big range. Do 1.5 times that. That times 1.5. Let's get the lower fence and the upper fence.
Will this be on the test?
This is really more for the final because we're going to focus on here. But I am curious about this because I looked at the graph and it looks terrible. Okay.
I'm sorry.
Lower fence is, here, let me finish this first. Lower fence is this minus 1.5 times that. And the upper fence is this plus 1.5 times that. Do I have any outliers?
Upper, lower, yes. No. Yeah, no.
My maximum's 248. It could go up to 413. There are no outliers. So we've met that condition. Okay? Go ahead and ask your question.
Wait, what's the lower and upper fence equation again? So it's 1.5.
Q3 minus plus 1.5 times the interquartile range.
Oh, Q3 plus
And you
1.5
find the
times IQR.
IQR is Q3 minus Q1.
And then lower is
Okay.
But we won't do that for this test.
Won't need that for this test. Okay, but I am glad that there's no outliers because that was bugging me. Okay. We could also do quickly a box and whisker plot. That doesn't look too bad. We should label it properly. Anyway, we're getting sidetracked. Okay, so we're going to assume this is normally distributed even though it's probably not. Okay? Any other numbers I need? No. Step number 2.
Oh, shoot, the type of test. It is.
Categorical or quantitative?
Looking at 88.
Where are all numbers?
No, this is quantitative. Yeah.
Quantitative.
Yes.
It's quantitative. Categorical, well, or we could use colors, right? Like your M&Ms is a chi-square independence test, right? So that's more than 2. Okay, more than 2 is going to be a chi-square test. Okay, more than 2 categories. Okay, It's quantitative. Step number 3,
Hypotheses.
no, the alternative hypothesis.
Null is that there is no difference. They're equal to each other. All beaches are safe.
Okay, what is all the beaches are safe? How do you make an equal sign? Mu
Equal to.
equals,
Wait, no, mu, oh wait,
And then parentheses.
less than, oh yeah, mu is less than,
what's a safe beach?
less than
Less than 88.
88 or less, right?
88 or less, yeah. Less than or equal to.
Unsafe beach would be
Greater than 88.
mu greater than 88.
Wait, would you not want to say mu
Is
is
less than
less than or equal to 88 for the null hypothesis?
Okay, read your directions on null hypothesis. What are the 4 things? Always has an equal sign, except for the chi-square test. Okay? All right. It's always about the parameter. No change, no difference, fair coin.
Right.
What's the 4th one I'm missing? It's usually not stated in the problem. This one kind of was, though. Well, the alternative was stated, right? Water is unsafe if it's more than 88. That's your alternative, right?
Right.
Okay. Step number 4. Pick the test. Is it a z, a t, or a chi-square?
Be a t-test.
Should we vote? We're going to vote. Who says it's a z? 1, 2, 3. Who says it's a t?
Shifts, I don't know anymore. Which was
1, 2, 3.
Wait, population.
Who says it's a chi-square?
It's not a chi-square.
Nobody. Who didn't raise your hand? You got it wrong.
Let me think for 1 more second.
So how do you know which test to pick?
How do you know which test to pick?
It's the t-test, I think.
Why is it
Why
a
would it be a
t-test?
t-test?
Because we don't have the standard deviation of the population.
Do we know the standard deviation of the population?
No. So it's t.
No, so it's a t-test.
So you have to know the population.
One sample. Do we know the standard deviation for the population?
No.
No, we only know it for the sample.
They need to give you sigma, and
They need to give you sigma.
So that's our only
Okay,
indicator.
sigma,
That's the only
That's so
indicator.
easy. So get a question. If it gives the standard deviation of the population, we know z-test. If it has
If it's
more-
quantitative.
If it's quantitative.
If it's categorical,
then it's t.
you can figure out the standard deviation yourself. You
you
don't
write
have
this
to know.
down, so then I can like.
Yeah, I did. It was
That's
called the
like-
outline. Remember that big outline I gave you? I wrote it down.
Yeah, I just don't know which test to choose, so if that's sigma, then it's a z.
Okay, go back to your outline. I posted the announcements and it's there. Okay? Now, the only thing about the outline is I gave you 2 more tests that are not there.
Or did you give it like as notes?
I gave it on Canvas. Okay? All right, what's the equation for the t-test 1 sample? T equals what?
E equals x minus x bar.
S over square root of n.
S divided by.
Is that what it says?
T-test, 1 sample. 1 sample t. Oh, t equals x bar minus.
So where is it on Canvas?
Oh, it does say that. That's actually not quite the right one. X. I didn't realize. That should say x bar minus mu. I didn't realize. So that formula is not quite correct. Over s divided by the square root of n. I thought apparently I grabbed an old version, but that test should say x minus x bar. Should say x bar minus mu, not x minus x bar. Yeah, that's what I wrote on there is correct. Your formula sheet is incorrect, so it looks like I need to fix that. Okay? It says x minus x bar, but it should be x bar minus mu. Okay? So you can have that, just cross it out. I won't use these again. Okay? So the paper that I just handed out to you is wrong. It should be x bar minus mu, just like I got here.
Did you say that we could keep it now?
We can keep it because it's wrong.
Okay, so it's x bar for t is.
Okay? So in this case, Suzette, can you help me punch this through?
113.75.
113.75 minus 88. And in the bottom, 93.9 divided by the square root of 12. Okay, so we've got my numerator divided by my denominator. We get 0.9499. What's next, Shire? What's step number 5? Find the p-value. Do you know how to do that? Is it norm S dist? No.
No.
It's T dot dist. You forgot what distribution you were using. T dot dist. Is it two-tailed, right-tailed, or one-tailed? How do you know?
Because our alternative is just greater than.
Because our alternative is greater than, so I want the right tail. Okay? What do I put in for X?
11. I'm just kidding.
0.9499. Your degrees of freedom? 11 degrees of freedom. Okay, 12 minus 1 is 11. And I got 0.81812. And Jaylin, what's step number 6? Reject or not. And the answer is?
No.
Are you sure?
Yeah.
Okay, good. Do not reject. And step number 7 is what, Olivia?
Right, I'm not. I'm starting this.
So you know step number 7, don't you? Can't hear you. What? Conclusion. What's the conclusion? Are you phoning your friend back there? Is she helping you?
Yes. Yes, she is.
Okay, what's the conclusion? Olivia? What's the conclusion?
I don't know.
I was afraid you'd say that. Are you going to ace my test? Brenda, what's the conclusion? Who agrees with Brenda that that's the correct conclusion? Is that you? One, two?
I also have a question. I also.
Okay. 3. Who disagrees? What do you think it is? No, she was right. Brenda was right. You need to study with Brenda.
So why isn't there enough evidence?
Why isn't there enough evidence? Because it's 113 and that's greater than 88. So why is there not enough evidence? Your p-value is greater than alpha, right?
Yes.
Okay. What's alpha?
What's your alpha? We never wrote down our alpha, did we?
No, yeah, that would have been.
0.05. That was
0.05, okay, so it's
because we didn't give it to you, so it's 0.05, right?
So it's higher than 0.05.
It's higher than 0.05, so we don't reject. Okay? So that's the main reason. What might be another reason? Standard deviation was huge, right?
Also, the population.
What might be another reason besides the standard deviation? Well, it's not normally distributed, but what might be another reason?
Is it even an SRS?
Is it an SRS? We don't know. We're going to hope that it was. Hope against hope, though. What might be another reason?
I feel like I'm totally missing out.
What about your N? Sample size was very small, 12, right? Well, you got to speak up so I can hear you.
I did, you said, yeah.
Oh, I didn't hear
What
you.
else?
Okay, Colin.
So if we were asked to use the chart, then our p-value would be greater than this.
Oh, if we were asked to use the chart, so we've got 11 degrees of freedom. In fact, we didn't write that down either. Degrees of freedom equals 11. Okay, so if we were to use the chart, which I have right here, okay, we're no longer on the standard table, we're on the T table.
Yes.
We're on 11 degrees of freedom.
11. So it's between 0.2 and 0.15.
Okay. What was the value I got?
0.94.
0.9499, right? Yeah, so I'm looking along here, 0.94, yeah, it's in between those two values, right?
So p is less than 0.2, but greater than 0.15.
Yeah. So your p-value with the chart would be between 0.15 and 0.20.
Sweet.
Okay?
So how did you find the p-value, the 0.15 and then the 0.2?
I just showed, but we'll do it again. Okay? Do you see this value here, 0.9499?
Yeah.
What value is that between
Oh,
on your 11 degrees of freedom? It's in between those two values, right?
Yeah.
So therefore, it's in between those two values.
Okay.
Okay? All right.
When are you gonna post the review for this?
When will I post it?
Yeah.
As soon as the class is over?
Okay. Let's take that.
Okay? All right. So, yeah, you just check it out on the YouTube channel. What's another good one?
Can you also post a Excel review, like portion?
You want this Excel posted? I can do that.
But also do like a review so that we know like what we need to go over in
Okay,
Excel.
so go over your old homework.
Okay.
Now, I'm going to pick one from chapter 22. Or do you have one you want me to pick? Because I think you should be able to do this.
Wait, have to
I thought you
on the
said you
test and we
wouldn't.
don't even know it?
We didn't.
Well, I told you I signed it, didn't I? Y'all told me you did it.
Well,
We did try to
but
do
we
it.
have so many questions. Like,
Okay, here we go. This is going to come from chapter 22.
So chapter 22 is gonna be on the test now or it's not?
Yeah,
it is.
What the heck? We don't even know.
yeah, you do.
You like showed us two equations last time.
Although, but to be honest, I already taught you this. Okay?
Oh, it's funny.
Although more than 50% of adults believe breakfast is important, only 30% eat breakfast daily. A cereal manufacturer contacts simple random sample of 1,500 Americans. Oh, I thought this would give me more information. And calculates p-hat who eat breakfast daily. Part A says, what is the approximate distribution of p-hat? And I'm going to add in the question why.
I would say
And B is, if it were 6,000 rather than 1,500, what would be distribution of p-hat? And why? That wasn't a good question, but we'll use it anyway. Okay.
So
I don't want him to answer all the questions. I want him to share the wealth. Kensley, what do you think? This is a good test question.
And we,
Brenda, what do you think? I'm gonna keep picking on everybody until I get to Colin. Shire.
With A.
Yeah.
Is this where you do like the, I don't know, like 15 times by 0.3, and then use that? to
15
divide?
times 0.3.
Totally odd.
I don't know where you got those numbers from.
Because from the 30%, not 15.
The 1,500 Americans.
1,500 Americans times by 0.3 times 0.7, right? So you just found NPQ.
Wait, I'm confused.
That's actually useful.
Wait, where's the point?
Why did you find that?
I don't know where you got the 0.7 from.
Oh, you don't know where you got the 0.7 from.
I didn't even say the point seven, you just typed the point seven.
And then you just.
I thought that's what you were saying.
Of the Americans.
I thought we were supposed to do approximate.
I just capped it at 0.3. 15 times 0.3 gives you 450.
Where did you get 15 from?
1,500,
just-
1,500, 1,500
Times 0.3
0.3,
equals
30%,
450,
equals
which is
450.
the approximate distribution. Is that not?
It's 30% of 1,500 Americans.
Okay, so you did 1,500
Almost.
times 0.3.
Then we could do the 1 minus 0.3, which gives you the 0.7. Is that it?
That's it. Okay, so why did I, so yeah, I thought that's what you were saying. That's why I finished it. So Shire figured out this number of 315, which was a useful number because, why? That's NPQ, right? She just figured out NPQ. And she found out that NPQ was greater than or equal to what? It's greater than or equal to 10.
Oh, shoot, you're right.
And so therefore, because it's big enough, therefore, P hat is normally distributed with a mean approximately at 0.30 or 30%.
So can you review how to do that really fast?
Use times multiplication.
What?
N times P times Q.
Yeah, what is it? So N is the 1,500.
P
P
is
is the
the,
proportion, which is 0.3.
and then you do
Okay.
1 minus the proportion of time.
Technically, that's, yeah. Okay? So that's what I was looking for on part A. If it were 6,000 rather than 1,500, what would be the distribution of P hat?
Do 6,000 times 0.3 times 0.7.
Yeah. Which is going to be a number bigger than 10, right?
Yeah.
So I really don't even need to do that calculation. Therefore, P hat is going to be normally distributed with a mean of approximately 0.30.
So we never
It-
do 1,500.
It will have a smaller standard deviation, however.
What's the distribution? Isn't that the
Okay?
1,500 times 0.3? Is that not the distribution?
All right. Because remember, if NPQ is greater than or equal to 10, then we can assume that it's normally distributed.
Right.
Okay? If this represents N equals 1,500 people, and it's going to be centered around 30%, okay? If I have 6,000 people, what is the distribution going to look like in comparison?
It'll be bigger.
It'll be a much skinnier distribution. It will also be at 0.30. Okay? Do we know what the standard deviation will be?
Find it out.
How do we do it on the?
It's the, okay, remember the equation Z equals P hat minus P over the square root of PQ divided by N. This is your standard deviation. Okay? So for the red, the standard deviation is going to be the square root of 0.3 times 0.7 divided by 1500. For the black, it's going to be the square root of 0.3 times 0.7 divided by 6000. I'm guessing this is going to have about a 3% margin of error, and this is going to have about a 1% margin of error.
So just normal P is like Q almost?
No.
Oh.
Normal P is not like Q.
You have 0.3 times
7.
But you're using.
We're assuming in this case that the P equals 30%, right?
P minus P.
Which means that the Q is going to be 0.7, 1 minus P, right?
I get it.
Now, let's make up a, what I thought this was going to do, that's why I picked the problem. Let me see if I can find another one.
So this is how you find the standard deviation.
Yeah, to be honest, these questions aren't very good.
No, we're not.
Oh, here we go. Here, let me do this one. This is a good one. This is a good problem from chapter 22. You guys should be able to do this one.
So this one is.
Okay?
A PQ over N.
A random, this is 22.5. A random sample of 1505 Canadians found 1,288 agree that firearms should be registered.
Hear about that shooting in Salt Lake that happened?
I did not.
Oh, yeah, no, not Passion Place. It was like all over the place. The guy like went around on a shooting spree and like robbed a convenience store.
Give a 99% confidence interval for proportion to support registered firearms. Okay? Okay, we're going to give it to Brady because he's sidetracking the class. Brady, can you help me do this?
Yeah, so give a 90% confidence interval. So you need your information for the confidence interval. So you need your X bar. So you need to find your mean. Yeah. You can't find the mean. I don't know.
Well, we know N.
So yeah, you know N, which is
We know that N equals 1505. Something equals 1288.
So I guess, you know how many agree and how many deny by doing 50 to 5 subtract.
So we can call that X, right?
okay, yeah. You need your alpha too.
Alpha divided by 2 is point. We're doing a 99% confidence interval. 0.005.
So you just did that. You did 5 divided by 2.
It's the same thing I drew up on the board here. 99% confidence interval. I want a 0.5% in each tail.
Okay.
Okay?
And
Now what?
we don't have, do we have
So
to?
if we don't have P, how do we get standard deviation?
We don't have P.
If it's concord,
What do we have?
N and X.
and out.
And that can tell us what? It's categorical. That's an important thing to know. Categorical.
The golden star.
And you don't need it. Or you can find it.
We can find it, right? If we don't know P, can we make an estimate of P? Yes, we can. What would be the estimate of P?
Can we just throw out a number?
Be P hat.
Is that not, do we get a percentage for that?
Okay.
It's like 1288 divided by 1505.
Ah, there we go. Equals 1288 divided by 1505. 85, almost 86% of Canadians say that firearms should be registered. Okay? Yes.
Q would be 1 minus.
Q hat would be 1 minus that.
So is that 14% say that no?
Firearms should not be registered.
Okay, that's 40.
Okay?
Okay, question. The standard deviation according to that was P times Q divided by N, not P hat times Q hat, right? So is there an equation where we find standard deviation P hat, Q hat rather than just P and Q?
Yeah, so remember when we learned this before, this is actually a different, I can't remember which chapter this came from. But it's on your formula. So when you don't have P, you can substitute P hat.
Oh, you can. So we just count it as P. And count Q hat as Q. That's nice. So multiply those together, divide by 1505.
What's the formula I should be using?
Equals.
What is it?
Yeah, the square root.
P hat, plus or minus Z sub alpha over 2 times square root PQ, well, divided by N. Okay?
You always use that one if it's categorical and you don't have the standard deviation.
Yes.
Okay.
It's categorical and you don't have standard deviation.
You guys are really scaring me.
Yeah, we're scared too.
Do we want to push the test off to next week?
Yeah.
Do you want to have a 2-day review?
Yes.
Oh, thank God. Awesome. Seriously. I will hurry and call the testing center and cancel all my testing. Because yes, I need more time for
Because I
this.
don't think they've processed this.
I won't,
It's a really good idea.
if I took it tomorrow, I think I would do well. Straight up.
Okay? I know, you guys are
Yeah,
scaring me.
you know that we were gonna do it.
So push
You
off
should
the
know all this. This is what scares me. Okay? Let's finish this.
So are we pushing the test back?
Yeah, we'll do another review on Thursday, which means what?
Tuesday.
Tuesday will be the written test for sure.
Okay.
And
Yeah, because we have a program.
I don't know about, I have to reschedule the computer. I don't think they've scheduled it yet. So, do you want me to open it on Tuesday? You want to do Tuesday
Yes, Tuesday I can take it.
or even Monday, Tuesday, Wednesday?
Yeah, Monday, Tuesday.
I'll have to see, or I'll give me a minute. Let's finish this problem and then we'll talk about the test, okay? So, who can finish this, Brenda?
Where are you at?
Trying to find the confidence interval.
Then you do.
I'm free Saturday too.
0.88, he had plus.
Let's go with the minus first. What's P hat? Or what's Z sub alpha over? No, we didn't get Z sub alpha over 2. What's Z? That was the one we missed. Z sub alpha over 2, which you guys are going to do now without the chart because you're smart. Norm S.
Inverse.
Inverse.
Oh, yeah, because you have the z-score.
How much do we want to the
Oh,
left?
no, you have the probability. 0.005.
0.005 will give me the negative number. If I want the positive number,
0.995.
0.995. Okay. 2.575. Does that sound familiar?
Yeah.
Sounds just like the last one we did. Which is funny because you guys couldn't remember that. Okay. All right. So now we've got that. So take it away, Brenda. So we got p hat minus
Oh. 2.57.
2.575
And then
times
square root of
square root of
we had times 1. Oh, that's
or q hat.
you have made it 1.144.
Mhm.
Okay.
Divided by
By n, which is 150.
okay. So how do I copy that, Brady?
So you copy the whole.
You can copy it up here.
Copy the equation, but then you need to change the minus to a plus.
Okay.
Like that. Press enter. There you go. And then you need to do your statement.
Okay. What's the statement?
We are what confidence? We are 99% confident. And that's below the alpha. Yeah, so
Oh, do we accept or reject?
Use the A word.
Accept. Oh, what?
Would it be?
I'm not supposed to.
So we are
Reject or not
99%
reject?
confident that.
We're not talking about a mean.
How do you say the A word?
I said accept.
Means refer to X bars. What do p hats refer to?
The Canadians.
What's the A word?
Portion.
The proportions of Canadians. Who support
Registering firearms.
registered firearms are 0.83, numbers 0.87 numbers.
Between the.
Numbers.
83.
So go at least one more decimal than they give you.
Okay.
And which you want to move to Canada, huh?
Yeah, that's high.
Except for it's cold up there. Who wants to go up there where it's cold?
But then Banff, come on. I can go there in August actually.
Yeah.
So, yeah.
I wouldn't mind. You know, Victoria is pretty nice, or Vancouver.
Vancouver would be nice.
Okay, except for it probably rains a lot there. All right, so here, let me go check and see if this room is open on Thursday. We'll see. You like this room better?
Yes.
Yeah.
Yeah, I do.
All of
the, I was honestly having a panic attack. Deep down.
Okay, so want to meet here at the all 3 rooms are open again.
Yeah, let's
So
meet
the
here.
same room?
Same room.
Okay, so we're going to meet here on Thursday for another day of review.
Yeah, know exactly where it is.
And then the Excel portion will be Monday through Wednesday?
I don't know. I'm going to do that right. I'll figure that out right now.
Okay.
Let me turn this off. But yeah, probably. We'll see.
Okay. Because I need to go and cancel my